Good morning. Can you enable screen sharing for me, please?
Yep, we're working on that.
Okay. So good morning, everybody. And thank you for inviting me. I really appreciate that. Let me just get all of these Zoom controls out of the way so you don't see a black dot. So my name is, as Jim indicated, is Willem Schroeder. I am the section traffic manager for Colorado, and I'm one of the officers of the Colorado Traffic League, which is basically the local incarnation of the National Traffic System. So the National Traffic System started back in 1915 with the American Radio Relay League. And in fact, the relay in Relay League refers to the fact that at a time where a gallon of gasoline cost about 10 cents, it would cost you around $5 to make a long distance phone call, or it would cost you a couple of dollars to send a telegram. And so there was a lot of amateur radio operators that got together and said, hey, we can provide the service where we will transfer messages that people would want to send and do that for free. So the traffic system started in the old days of the original digital mode CW, of sending short messages that says, hi, I arrived safely, or hey, we just had a baby, or whatever other information you wanted to pass to people when at a time when doing anything else in a very expedient way was very expensive. In recent years, there has been sort of a resurgence as a result of some politics. There's a separate group called Radio Relay International, RRI, that formed, that is independent of the ARRL. ARRL also have a program going right now that's called NTS 2.0, which seeks to sort of modernize and update a lot of the procedures. But in the long run, you know, all of this we still refer to as just the National Traffic System, regardless of who actually is the official author or sponsor of the system. So the question is, why do we still need the NTS, right? In the recent years, where your long-distance phone calls are essentially free and cost the same as a local phone call, you know, why do we need this? Well, a great example occurred in 2020 when there was a tornado back in Tennessee, and one of our local operators' sister, who lived there, didn't let them know that she was okay. So what we actually did was to send an NTS message. It was specifically what's called an ARRL 18 message. And essentially what it says is, please contact me as soon as possible. Here's my phone number. Well, what actually had happened was his family was okay, but in the process, they had lost their cell phone. And
recording in progress.
None of us remembers phone numbers anymore. So the phone number was stored in the phone and they had lost the phone. So the cell service was up, but they didn't have the number to call to let people know that they were okay. So a local NTS operator got the message, got in his car, drove over to their house, and basically said, hey, here's a message from Wayne. It says, please call me. This is my phone number. And within 2 hours of actually sending the message, they were able to call and let them know that, yes, they had some damage. They lost their phone, but everybody is okay. So, for those kinds of health and welfare operations, the NTS is still ideally suited. The other big thing, of course, is that it gives us the ability to practice reading messages at a speed and with a cadence that somebody can actually write that down. So the whole goal is to be able to convey a message with great accuracy, doing it efficiently, but also be accountable, right? So actually keep track of what messages you pass to whom, and have a record of all of those things. And so overall, participating in NTS simply makes you a better radio operator. And so it'll give you some very valuable skills if in some organization like ARES or in the wildland fire or whatever public safety or other service you will do, it just gives you the ability to be a much better operator and read traffic and copy traffic in a more a much better way. So the NTS is organized in basically local, regional, and area groups. So typically, if we want to send a transcontinental message at a local level, you would join the local net, pass the piece of traffic into that. That will get passed up to the regional net if necessary, and from there to the area net, where it then gets transferred to the local area. So in all of these nets, voice is most common on local nets, but you could also use packet or some other digital mode to actually enter the traffic into the system, and it will then get routed to the local area where the message is destined for, and then get delivered via either a telephone call or in person, depending on the particular circumstances. So just to give you an idea of how this is all organized, the United States and Canada basically cooperate. The Pacific area is basically from Colorado to the west. The eastern area is basically the eastern seaboard. And then the central area is basically everything in the middle. So Colorado is part of the Pacific area, and we're also part of the 12th region. The 12th region being the 5 southern states, Wyoming, Colorado, Utah, New Mexico, and Arizona. So the basic tool that we use to pass these messages is called the radiogram form. So the purpose of the radiogram form is to have a standard format that we can use to accurately and efficiently convey the message. The radiogram has different parts. So the first part is what's called the preamble. I'll go into the details of it in a minute, but it's basically a header that tells you where the message is coming from, what its priority is, and how we want it to be handled. Then you need the address of where it's going to, the body of the message itself, which is the actual message that you want to convey, the signature, which is basically who it's coming from, and then some bookkeeping, how you actually sent and received it. You can download a copy of this particular message from the website. So www.kilo0novembertangosierra.org is the website for the traffic lead. You can get this information there. So how's the radiogram different than, for example, an ICS 213 that we use for most ICS or ARES related messages? So in the first place, the radiogram anticipates that there's going to be many relays needed before it gets to its destination, right? So NTS is more geared towards long distance traffic. And so what we need is a complete address and typically a zip code and a phone number in order to be able to deliver it. Most of the operators that are involved in passing that message is not going to know either the recipient or the sender. So where in some sort of an incident, the ICS 213 just say, it's from Joe to Frank, and you know who Joe and Frank is. With the radiogram, it's important that you actually give complete delivery information so that the receiving operator can actually deliver that to the appropriate person, and also enough information so that we know how to route it. So most NTS messages gets routed by the zip code. So the zip code is then used to get it to an operator that can locally deliver it. And if the phone system is operative, they can make a phone call and actually deliver it. Or as I illustrated in the previous example, if you have a street address, they can actually go and deliver the message by hand. There's a priority in the radiogram. So whether it's a routine message, a priority message, health and welfare, or an emergency message, basically tells the people that are handling this message whether this message should be handled as fast as possible, or whether we can just pass it on in a routine way. And then the handling tells you things like, are you expecting a return message? Does the sending operator want to confirmation that the message was actually delivered, or is it best effort? What exactly needs to happen? Then, of course, the other thing is that there's a check in the header that helps you ensure the accuracy to make sure that all of the words got passed. It's like a checksum, although it just counts the number of words. And the other thing to take into consideration is that most of the time you're going to want to have a reply come back. So you need to make sure that there's enough information in the signature so that if they wanted to send a reply message, that we have the information to actually send something back. The radiogram does have some limitations. There's a recommended 25-word limit on the radiogram, just because it's going to often be passed by voice. And so you don't want to make it too long, although that's not strictly enforced. The delivery time may be slower, depending on just if it's a routine message and there's a lot of emergency or priority traffic, the routine traffic may actually be delayed a little bit. And it also, of course, depends on actual people being there to be able to deliver it. And then that last mile obviously relies on there being a local operator that can actually handle that message, either to make that phone call or get in his car and actually go and deliver that. So again, being part, or at least have some experience with the system would be of great aid in the case that you may want to serve that particular role. So just here's an example of a particular radiogram. This is the kind of radiograms that we use for practice. So like I said, there's not a huge call for radiograms these days, except for emergency situations. So many of the radiograms that you will hear passed is typically things that remind people that their license is about to expire, or welcomes them to amateur radio and things like that. This is one of those license expiration one that has been filled out. This is coming from KX6XXX in Los Angeles, California, and it's going to Joe Schmo in Lakewood, Colorado. And you can see there's a zip code and a phone number associated with it. The preamble is really the critical part and what people find the most confusing. So the first thing is a number that you associate with the message. This is just a number that you make up if you were to create the message, so that you can keep track of all of the messages that you're sending. And it's completely up to the person putting this into the system as to what that is. The next is the precedence. So the precedence says how important this message is. So this one is a routine message. The other options that you have is W for welfare, P for priority, or emergency. And if it's an emergency message, we actually spell out emergency, and that obviously gets the highest priority. Then the handling instructions, which is abbreviated Hotel X-ray, is, for example, C means that once you've delivered that message to the final person, send back a reply to the person that put it in to let them know that that message was delivered. Hotel X-ray Echo would, for example, mean get a reply and send back a reply once you deliver it, or asking the delivering person if they want to send a reply back. Hotel X-ray Golf basically means, I'm hoping to reach this person, but I'm sending them a birthday greeting. So if it's going to cost you a lot of money to actually make this and have to make a long distance phone call, don't worry about it. So routine traffic often has that Hotel X-ray Golf designation. Then, of course, the station of origin is whoever enters this into the NTS system. That's typically the person that you would want to send a reply back to, because they will keep track of who entered the message into the system. So the reply would go back to them, and they are then responsible for contact the person that actually is the originator of the message. And so this is the amateur station that's putting this into the system at the beginning, not necessarily the person who the message is from, who may not be an amateur radio operator. The check is the number of words in the message. This is only the message part, so not the address. So we're just keeping a track of the number of words in the message, where it's coming from, in this case, Los Angeles, California. The time filed. Time filed is kind of an optional field. We typically use that in priority or emergency traffic. For routine traffic, that's usually omitted. And then the date that the message was entered into the system. If you want more of the details, FSD 218, which is on the ARRL website, will give you more information about the particular fields and a little bit more detail about how to fill it in. One of the most important parts of the radiogram, of course, is the address. So in this case, it's Joe Smo. He happens to be an amateur radio operator, so we'll add his call sign. But of course, the call sign wouldn't be there if it was just sent to a regular person. The most important parts here is the street address, if it needs to be delivered by hand, or a phone number if there's a hope that there's some local phone systems still that are active. And then, of course, to route it to the right delivery operator for the last half mile, we need that zip code. So typically, the town and the zip code is enough to actually find a local operator that would then be able to deliver it. Of course, the hope is that there will be local phone service, so a phone number is always useful. And then, of course, just as part of our bookkeeping, if we are going to actually create a paper radiogram that we're going to hand to somebody, we would typically fill in our information as well. So the receiving station will fill in his name and call sign and an address and phone number, so that if that person needs to send a reply back, they have contact information of a local NTS operator to actually be able to send a reply message. We would also fill in the received block at the bottom. So the text, of course, is then the actual message itself. In this case, it simply says your amateur radio license expires on January 16th. Be sure to renew 73. And so we write this sort of in the telegram style. Typically everything is written in uppercase, although that's just a convention. Special punctuation such as periods or question marks are written as X-ray for a period, or stop in the old telegram form, query for a question mark, A dash would be written out as a word dash and so forth. But typically we skip the punctuation. It's the words that matter. And so the number of words are typically written 5 to a line, and there's 5 lines provided on the radiogram, which gives you a quick way of counting the number of words in the message, because as we transfer it, we want to make sure that we don't lose anything in the process. X-rays are typically optional unless it's important for the context, that you know that this is the end of the sentence. And so, for example, 73, we would actually omit the X-ray before it because it really doesn't do anything. And then finally, the signature is who it's from. This is actually the person who is sending the message rather than the operator who's handling it. And so that would be, in this case, John KX6XXX, or it would be Aunt Flo if it's somebody who's actually sending the message. And in the signature, you can also add things like a return phone number or something of that nature if it's important to be able to get the message back. The last thing that you'll fill in there, of course, is the accounting. Just if you sent the message, who you sent it to, and the date and time, and if you received the message, who you received it from, and again, the date and time. We use UTC universally because these are typically going to go across time zones. So we want to make sure that we keep our time straight. And so in this case, you can see there was actually a date rollover in that message. To actually speed up transmission, there are these ARRL number texts. There are now also RRI number text. And these are things that you can find, excuse me, in FSD3. And so, for example, when I sent that message to Tennessee, instead of saying, please call me, this is my phone number, the message I sent was ARL 18, which basically means, please contact me as soon as possible at this phone number. And so it's just ARL 18 and then the phone number. So it's basically 3 words, if you count the phone number as a single word, instead of having much more detailed text. And so when you include one of those abbreviations, it makes it easier to send it. It's much shorter to transfer, and it's also unambiguous as to what the meaning of it is, and you actually just fill in the appropriate parts of it. I encourage you to look at FSD3 to actually look at those. The important thing to do is that ARL 18 is a word, right? It's EAIGHTEEN. It's not 18. So you actually send that as a spelled out number as opposed to using digits. Of course, in recent years, we've actually relied much more on the NTS digital system. So NTSD works similar to how email works, except it actually uses radio to forward it. NTSD started after World War II using surplus RTTI data or hardware, but in more recent years, we've basically used packet radio for VHF and UHF, and we rely largely on PACTOR on HF. And the NTSD system is also well integrated into WinLink so that you can both originate messages from WinLink and pass it into the NTSD system. And we can also use WinLink system to actually pass NTSD messages if we don't have any other options. Of course, the advantages of the digital system is that it's available 24/7. It's fully automated. So all of the intermediate hops don't necessarily have to have a human being there. And it is frequency agile. There's multiple paths that it can follow. And just like, email or things like that, there's multiple routes that it can follow to get to various points. So I'm not sure you're going to be able to read this eye chart very well, but I just thought it would be an interesting illustration This is an NTSD message that I received. It came from Germany, from KB0NTS, who is one of the stations that is operated by a German station, Delta Lima 4 Foxtrot November, who's very active in the NTS system. So he actually sent me this message, and the NTSD system actually keeps a record of how that message was forwarded. So you can see it was entered by DL4FN into a station called DB0NTS. That went through a couple of other hops in the German system. It was transferred from Germany to KW1U in Massachusetts. From there, it got transferred to W5 KAV in Washington. It went there from there to NS7K in Utah. Then it went to WA0R in Colorado, and finally into the K0NTS BBS that I have up here on the top of the hill. The other thing is that you can actually keep track of the time. So this was just a routine message. So it was started at 12:24 Zulu on the 7th. It arrived at 3:30 on the 8th, again, Zulu time. So it took a little more than 12 hours, actually closer to 15 hours to actually show up here. But you can kind of see in the gaps in the time where there was propagation issues, right? So, for example, between Germany and Massachusetts, there was a 6-hour delay before it actually got forwarded via probably a 20-meter link. And then there was again a delay between NS7K and Colorado of around 6 hours, again, probably related to just propagation. And then, of course, here's the message itself. In the digital system, we actually don't prefix every field with what it's meaning. You basically get that from the position, but it's message number 64, routine Hotel X-ray Golf from Delta Lima 4 Foxtrot November. It's an ARL 23, so it contains ARL in the message, but there's 23 words. It came from Urbach, Germany on July the 7th. There's the address. The BT is the break between the actual header or the address and the message. And then there's again a break before you get to the signature, as well as an operator note. So just sort of out of interest. If you want to use WinLink to actually originate radiograms, it actually has a very handy form. So this is a short message that I generated, send it to my YL, and you can basically use these drop downs to actually do this. So if you're using the WinLink program, you're simply going to go into the forms, you look for the radiogram form, and you fill this out. The key thing to put in here, of course, is make sure that you have the state and the zip code filled out. What's going to happen is that it's going to be forwarded from WinLink to the NTS digital system. And the NTS digital system needs the state and the zip code in order to actually route it. And then down here, you need to say what the liaison station is that's actually going to do the transfer between WinLink and NTSD. So in this case, region 12 is the K0NTS station. If you pick region 12 there, it'll get packed up by our local BBS and actually fill it in. And this will help you fill in all of the fields correctly, give you the right check in terms of the words and so forth. So again, a very convenient way of doing this. So how do you operate in the NTS system? Well, like anything, we want to make sure that we use good amateur radio operating procedures, speak clearly and use a crisp enunciation, use standard ITU phonetics. For people who like me who talk funny, those ITU phonetics were specifically designed that even people with an accent will be well understood and there wouldn't be a confusion about what the words mean. If there are ambiguous words, you spell them out. And we use pro words as a prefix to certain things. So for example, if I'm going to have a street address like Beaver, I would say I spell and then spell out the word Bravo Echo Alpha Victor Echo Romeo to actually make sure that the spelling is correct. If there's an amateur call mentioned, you would say amateur call and then spell out the amateur call. If you're going to have a number, you would say figures and then spell out the digits. So it's not 3,840, it's 3840. You basically read the digits one after each other. If there are initials, you would say initials and then spell out the initials phonetically. Or if it's a mixed group like 12, you would say mixed group 1, 2, Tango Hotel. So getting used to using those pro words that helps the person on the receiving side know what is coming next is really important in terms of getting the messages passed accurately. And the great thing here is that the first time you do this, you're probably going to screw it up. Certainly I did. But just practice, participate, and do this. Receiving a message is actually really easy. The much more difficult part is sending a message in such a way that the person on the receiving side understands what's going to come next and can write things down. So 100% of the time, you're going to do it too fast. So just sort of practicing this and developing that cadence to get a sense for how fast somebody on the other side could actually write it is something that you can only learn through practice. So I would very much encourage you to participate and in practice this. So if you would like to take part in the Colorado Traffic Net, that's every evening between 7 and 7:25 Mountain Time on the Colorado Connection repeaters. You can both copy traffic there. If somebody else is passing traffic, maybe you just copy it down to get some copy practice. But really, the sending practice is the really important one. So send birthday greetings to your grandma or whatever kind of message you want to send just to get some practice at that. We also have an HF net at 6:45 Monday through Friday on 3989 lower sideband. And all of the information about these nets are available on the K0 NTS regional or website. That we also have a region net, the 12th region net at 7 o'clock every morning on 3923.5. That's usually a very short net, often just 5 minutes or so. We'd encourage you to jump in on that. If you want to participate in the digital system, at here locally in the Denver area, we have the K0 NTS BBS. It's on 145.050 and 441.075. The -1 SSID is to access the BBS. It's also an RMS gateway into WinLink, so you can access that. I'm not sure what the status of W0QEY is, but these W0QEY and K0 NTS is actually linked via the RMM backbone. So you can also access it through that local BBS, which I think is on 145.030, although it was down for a while, so I'm not sure of its current status. K0 NTS also has a HF presence. It runs Pactor 1, 2, and 3 for if authorized in emergencies. On HF, the call sign is always K0 NTS, but there's different frequencies for whether you want to access the BBS or the RMS. So it scans those three frequencies on 80, 40, and 20 meters. And then for the RMS, it's only on 40 and 20 meters. You can access the BBS that way. just as a matter of interest, here's actually a picture of what the BBS looks like if you actually want to come and see it. So up here in the top left-hand corner is basically a Raspberry Pi that runs the system. It's basically a BPQ node. There's two TNCs mounted right on it. And here are the two radios for VHF and UHF. Here's the HF radio with a Pactor modem and the antenna tuner down here. There's also an iGate, which is basically on just a receive-only iGate. And then the rest is just power controls, the connection to the RMM backbone, and then a backed up power supply here. So basically, this is the heart of our system, and all of the traffic that we receive either by voice or by digital typically gets posted to this BBS, and that's what we use during our nets to actually deliver the messages or enter the messages into the system. So I went 5 minutes over my allotted time, so I appreciate that, your guys sticking around. But if you have any questions, I'm always available. My email address is my call sign at k0nts.org, or you can always just step by during the traffic net at 7 o'clock or 6:45 on HF. And if you have any questions or you want to jump in, please do so at any time. Thank you for your attention.
Well, back in the
oh,
dark ages, when this was done on CW, we were told that the message, all the figures were to be spelled out. Has that requirement changed?
For the radiograms, yes, you always have to spell that out. What I've heard mostly is people just send the digits directly in CW if it's something like a phone number or something like that. But it wouldn't hurt to send them as words. The only problem would be then if you actually translate between voice and CW to stay consistent. It basically a 10-digit phone number now becomes 10 words. Anne asked, what's a BBS? So a BBS is a bulletin board system. Basically a concept from the early internet. It's simply like a message board where the messages actually gets posted as individual messages, and then the BBS has certain keywords like read or send that you use to actually read a message, and it basically is just like an email program that you would read the actual contents of it. So the difference between a BBS message and an email message is that the email message is directed to a person. The BBS message is basically posted as just an entry that anybody can read, either to deliver the message, or if the message is directed at you, then you can obviously read the message directly.
Willem, am I on?
Yes.
Okay. I think we're showing our age when we talk about BBSs, aren't we?
No comment.
I remember that we had a couple in town here. It was the original internet, guys, I guess you could say.
Well, it's about the same time as the BBS system for radio was developed. It's just it didn't rely on the internet, because at that time, of course, the internet wasn't free the way it is today. It was more of a closed system, and you had to basically do dial-up.
And then you had to pay for the long distance phone call too, or AOL, or CompuServe.
Exactly.
Did you have a question, Doug?
If nobody else had a question, I was just, hi Willem, K2AD. And we were all admiring your background. And at the table here, I said, well, that's not a fake background, when we noticed all of your rigs in the back. You might give a brief shack tour, but I've already seen it. So thank you for being here. And I'm going to go to the buffet and get another piece of key lime pie.
So what I should point out is what I'm pointing out here is a PDP 1170. So it's not an original PDP 1170, but it's actually an FPGA implementation in hardware of an actual PDP 1170, and it runs BSD 4.4. So it actually has an Ethernet connection that you connect to. Over here, we have a whole bunch of Yaesu FT101s, because in the mid-70s, when I first got into ham radio, I really, really wanted one and didn't have the money for one. And now whenever I see one, I buy it. So I have 5 FT101s. And there's also a TS710 and an FT221 VHF all band, all mode radios there in my collection. And of course, you know, the station monitor and the speaker and all the associated accessories.
Well, Willem, Joe, I want to thank you very much for doing this. And I want to say to everyone, when I first started with the Traffic League, if it wouldn't have been for Willem and Leslie, I would have been in big trouble. They're very kind, and I recommend everybody to get involved with these guys. They're very kind, they're very supportive, and they give classes like you wouldn't believe. I can't think any. A good word for you guys is you're the best. So thank you so much for doing this and for actually doing the Traffic League. That is an excellent thing, I think.
Well, that's very kind of you. I see there's another question in the chat here is, so if you have a message that reads ARL 46, so ARL 46 means that, well, I don't remember what 46 is happy birthday, or was it Merry Christmas? So those would be 3 words. So ARL, which is Alfa Romeo Lima, 40 is the next word, and 6 is the third word. So those 3 words, or those 3 messages would count as 3 words, but of course it means a longer sentence. So in that particular instance, you would count those then as 3 words. Phone numbers, we typically make 3 words also, right? So you have the area code, the whatever the next 3 digits are called, and then the last 4. We often send as 3 groups. And the way that you know that it's not just a 10-digit number is you would say figures 303, figures 215, figures 5555, right? So if by injecting figures in between those 3 words, you know that it's a number group that goes together and should be counted as 3 different words. So before we had the BBS in the more electronic way of doing things, it was all done on paper. So the original, teens, 20s, and 30s, it was all just this little paper card that you would fill in as you basically copy down the message. And typically it, since local phone calls was also expensive, what typically those ham radio operators would do is it would take that card and hand deliver it to their neighbor with the actual message in it. You can still actually buy from the league. I may have one right here. This is actually a printed one, but basically just it looks like a postcard. So here's the radiogram side of it, and then on the other side of it, you can put your address and phone number, and so basically deliver it either by mail as a postcard or just hand deliver it to and to whom the message goes. But today, most of the time, we're just going to make a phone call and deliver a message.
Any other questions? Well, again, Willem, thanks so much for being here. I do appreciate that, and I thank you very much.
This presentation was brought to you by the Northern Colorado Amateur Radio Club. For more information, visit our website, ncarc.net. Thanks for watching, and don't forget to like and subscribe.